Good evening, everyone, and welcome to our second session of Boston Virtual ARTCC's Ground School. My name is Evan. I'm the Community Manager here at Boston Virtual ARTCC, and we're happy to welcome members from BVA, VATUSA, and VATSIM to tonight's presentation on weather. Once again, presenting for us today are CFIs Alec and Krikor. They're both controllers here at Boston, and as well in the real world, they both instruct in real airplanes. And so they're very familiar with the concepts of weather. Both of them currently live in the Southeast, where thunderstorms and rapidly changing weather are a thing that gets dealt with almost every day. So they'll be happy to walk you through how that translates to the simulator. Unlike last week, everything we're doing is here via Google Meet, so you should be able to hear us and see the slides. If you do have any questions as we go, feel free to use the chat, or if you prefer, just unmute your microphone and speak up. We've also got a few volunteers that'll be helping us with a few things later on. So if you are going to speak or if you have a question, you can unmute your microphone by clicking the button in the bottom. There's a little white bar. Just click on the microphone icon. That will unmute your mic. And of course, you're welcome to ask questions via the chat as well. So I think without any further ado, I'll hand it off to Alec and Krikor to walk us through weather.
All right, thank you for that, Evan, and good evening, everybody. Again, my name is Krikor, and along with Alec, we're going to be talking today about weather. Just before we get into this, I do want to make it clear we're not getting super in-depth with weather theory or all of the weather tools that you would have available to you if you were actually flying, so please make sure that you're only referencing this in kind of a VATSIM context and not, going out and flying an actual airplane based off of this information.
Yeah, to elaborate on that, this is very, very geared towards flight simulation. Please, please, please do not use any of these tools, but only these tools for real-world flight planning. That is much more involved and much more different set of resources that are more applicable to real world than flight sim.
So, with that being said, today we're going to start by talking about weather in the flight simulator, different tools that are available to you, different programs that you can use, different ways of injecting weather into the simulator. And after that, we're going to begin to talk about some specific weather things, certain weather resources you can use for flight planning and for performing a flight, some tools that are used in the real world that can also be used on VATSIM as it pertains to weather, and then basics of decoding METARs and TAFs, which are, again, some of those basic weather tools that are available during a flight.
So this is a screenshot taken a little bit of a while ago in FSX with the default weather turned on. And this default weather in simulators leaves a lot to be desired, partly because it can have some effects that you would just straight up never find in the real world. For example, here, Evan was flying along and a 100-knot headwind suddenly sheared to a 100-knot tailwind with no warning given. So aircraft lost 100 knots and stalled. In the real world, you're not going to find something like that. And this is just one of many examples where default weather in Flight Simulator just doesn't cut it most of the time.
So with that being said, there are a couple additional programs that you can use in your simulator to inject world weather and make things a little bit more realistic. By far the most recommended is by Hi-Fi Technologies, and we call it Active Sky, or that's what their program is called. They have a variety of different Active Sky programs. You can find out more on their website, hifisimtech.com. But essentially what this does is it takes real-world data, both METARs, TAFs, winds aloft, convective activity, all of that information, and injects it into the simulator. And it does it in a way that it's not super noticeable when it updates. So when every, I don't know what the actual update rate on it is, but let's say every 15 minutes it injects new weather. It's not going to do so you suddenly have a wind shear change of 75 knots. It injects it slowly in a way that's realistic and manageable, so you won't get things like that crazy Air Canada screenshot that we were just looking at a minute ago. The program has been long known for FSX and Lockheed Martin Prepared. However, they recently added an X-Plane version of the client as well. There are some additional steps you need to go through with X-Plane as far as setting it up. You don't just open the program and run with it. But for the most part, it's pretty intuitive and it works very well. There are some additional free or other paid resources you can see on the right there. One of the ones we have listed here is FS Real Weather, which has a paid and a free version, and you can see the information there on the right side of the screen how to obtain that program. This program would be better than nothing, but the use of Active Sky is strongly encouraged. It's widely regarded as the best weather program that's available. for most major simulation platforms.
Yeah, I've been advocating for Active Sky for years, way back to the FSX only days of 2007 and 8. And for people who like to fly in the simulator, even if weather isn't your passion, Active Sky is fantastic. The METAR that you see in the actual simulator is going to match exactly what the real world one does. The altimeter setting that you're given by air traffic control on VATSIM, that's going to be the altimeter you set in your airplane, and in fact, it's going to be exactly correct. You might have seen a few times or heard a few times that ATC will say, hey, we're showing you at 3,300 feet, even though you're showing yourself at 3,000. You check your altimeter and you're using the correct one. What's happened is that your simulator's weather isn't actually matching. So your simulator might have a different altimeter setting, and that's causing the issue. If you want to see the clouds where they're supposed to be, the rain where it's supposed to be, an accurate depiction of what the weather should look like, Active Sky will give that to you. And the default weather in certainly FSX and P3D doesn't even come close to that. And for X-Plane, I think X-Plane's default weather is at least a little better, but still, I think there's improvement that you can get out of Active Sky in either of those cases. It doesn't have a huge rate of performance hit, really. I think pretty much negligible these days is what Active Sky's performance hit is. And as Krikor said, it does a really nice job of injecting smoothly. And beyond that, you also have the advantage of being able to do custom weather. So if you want to put a certain cloud layer somewhere, you have that ability in much greater detail than you can do with the default simulation abilities.
Yeah, so we're going to go through here a couple of pictures and look at some of the capabilities of Active Sky. One is it looks good. You get more textures, you get better sunsets, more realistic transitions during the day. You'll get scenes like this that look good, I guess, for lack of a better word. Again, there's usually more depth to clouds. Active Sky typically brings clouds that are a little bit more three-dimensional than the default.
One thing to add is sometimes Active Sky also comes, you can buy a package with something called Active Sky Cloud Art, which takes clouds to a whole new level and really makes them look perfectly realistic. So the clouds that Active Sky comes native with are very good. Then if you buy the Active Sky Cloud Art package along with it, which we strongly encourage, but I mean, this isn't a sales pitch, but we strongly encourage it because everybody we know uses it, it ends up being a very, very good looking simulator.
One of the largest benefits to something like Active Sky is if you're doing instrument flying and you want to fly approaches down either to minimums or somewhere lower than you would on a good VFR day. It's hard to see here because the picture, the bottom of the screens are kind of cut off, but this is a 737 on, it looks like the final approach into Boston on one of the ILSs, and you can see it. It's just like you're actually flying in a cloud at night. You can't see anything. There's no visual references outside. Excuse me. And that adds a lot of depth where you'll actually have realistic ceilings and bases and clouds that you fly through. That adds a lot of immersion to the simulator.
So now we're going to talk about METARs and TAFs. How do you actually figure out what weather you're flying through? A METAR is an hourly weather report from weather observation stations, and if there's particularly bad weather or it's changing quite rapidly, you will have a SPECI, which is a METAR that is issued half-hourly or as needed. It can be heard on AWOS or ASOS, which are automatic radio reporting stations, or by radio and telephone. You can literally call an ATIS and have it read back to you over your telephone. And you will have the METAR available in the ATIS information when you're flying into a controlled airport. It is in a coded format, which we will explain in a second. It'll apply to a 5-mile radius around the station that it's broadcasting from. And it's generally pronounced METAR. Some people will pronounce METAR, but I've always heard it as METAR, and I think Krikor has the same.
I've heard METAR as well.
Okay. So either one of those two is fine.
You guys said I was crazy when I said that, but I didn't write this slide. It was like that before I got here, just for the record.
Yeah, so either one of those two, METAR, however you want to pronounce it. And then you have the Terminal Aerodrome Forecast, which is the TAF. Very similar codes to a METAR. You also using a 5-mile radius around the airport, but that usually has a 24 hours, occasionally a 36-hour validity.
And an important difference here is a METAR is an observation. It's a recording of something that happened and that a number of, in this case, it's a bunch of sensors and instruments that they observe. A TAF is a forecast based on models and statistics and all that fun stuff.
But you'll find they're very good at updating TAFs right after something they didn't predict happens. Like, it's amazing. You totally see something unpredicted, and then 10 minutes later, the TAF has changed, and it's like, oh yeah, we're going to see this happen that's already been happening for the last 10 minutes.
Apparently, whoever writes the Nashville TAF hasn't figured that out yet, but I digress.
We actually used to have to print out the weather anywhere we went at the old operator I was flying for, because if you actually had an encounter where you had to do a pop-up IFR, or you were planning to fly VFR and it didn't work out, we basically had to be able to prove to the regulators that the weather was supposed to be good enough at the time. And you would, go somewhere with a totally wide open looking TAF, and then you'd land in IMC or pretty close to it and look back and the TAF has changed. And it's like, oh yeah, actually it's supposed to be IFR for the rest of the day. It's like, thanks guys, that was helpful.
Yeah.
So right. I used to say never trust a TAF.
Yeah, fair enough. Well, truly always fails, right? Anyway, here is an example of a METAR. Now, normally they wouldn't be bright and rainbow colored like this. That's just for our sake and being able to go through it step by step. But we're going to basically go through all the different portions of a of the TAF here. And sorry, I stepped on my HDMI cable here and my monitor just came unplugged. Okay, there we go. So we're going to go through each of the different sections of the TAF, kind of discuss what this information is, what it's, the METAR, excuse me, go through all this information, how it's coded, what it's telling us, and you'll see that even though it looks very confusing, and if you haven't seen this before, it looks like a big jumble of letters and numbers, the format is consistent. And so once you understand how to decode one METAR, you normally understand how to decode all METARs. So let's go through this one colored portion at a time. The first is KBOS. That's the ICAO, or International Civil Aviation Organization code for the airport or weather station. It's normally an airport, but there are certain stations where it'll show, I think the Blue Hills Observatory near Norwood, Massachusetts has puts out METARs. So it could be an off-airport location, but it's going to be the 4-letter ICAO identifier for wherever the observation is. And remember that these METARs are generally valid for 5 statute miles from the weather station. The second portion is the date and the time of the issuance. So in this case, it's the 15th day of the month at 0054 Zulu. So remember, in this case, we would need to convert back to local time to try and make sure that it's a valid TAF, or METAR rather. And the other thing is, in this case, it's from 0054. So going back to a local time is also going to change the day in this case. So that's just a conversion thing to watch out for. The next portion is the wind. In this case, the wind is coming from 290 degrees true, so relative from true north. That's the direction the wind is coming from. So it is blowing from the west to the east at 6 knots in this case. And as you progress through your pilot experience, you'll kind of get a feel for what's a lot of wind, what's not a lot of wind, what's dangerous, what's safe, that kind of thing. If there were to be gusts in the wind, if it was, occasionally blowing to a stronger value, you would see, in this case, like 290 at 06, and then the letter G, and then whatever the gusts are, like 13 or whatever the case may be. The next portion is the sky cover. Normally there are a number of things here. It could include, in this case, 5 SM is the visibility, which is 5 statute miles. Oftentimes you'll see 10 statute miles. That is the highest number that METARs in the United States report at, is 10 statute miles. That usually doesn't actually mean 10 miles. It's just 10 miles or greater. So once that number starts to drop below 10, it's a lot more apparent than you might think. The first time I flew an 8 miles visibility, I was like, wow, this is really not a whole lot. We can't see all that far. So that's the first portion of that. And then after that are the clouds. And we'll talk about this more in a minute. There's a second slide that covers some of this. But the 3 letters, so FEW, SCT, BKN, stand for the, not concentration, but the brokenness of the clouds. So in this case,
sky coverage percentage in eighths. Sky coverage.
Well, yes, but okay. So how broken the sky coverage is, and so it lists the type, and then 3 numbers that signify the altitude of the bottoms of those clouds in hundreds of feet. So in this case, few clouds at 1,000 feet, scattered clouds at 3,500, and broken clouds at 7,000 feet. Those altitudes are all AGL, above ground level, so you'd have to add that to whatever the airport elevation or the station elevation is to get a altitude above sea level, or a true altitude. Next is the temperature and dew point. These are both expressed in degrees Celsius. So temperature in this case is 21 Celsius. The dew point is 9 degrees Celsius. The closer these are to each other, the higher the relative humidity is, and the higher the chances of saturation are. So when that spread gets close, when it gets within 2 or 3 or 4 degrees, you want to start looking for low clouds, fog, that kind of thing. Next is an altimeter setting, which is barometric pressure. That's what we set in the airplane. So 2, 9, or 9 or 3 inches of mercury. They omit the little dot in the middle there on METARs, but it does still exist. Then you have the remarks section. You normally will see RMK. What comes after it can change. Most commonly, you'll see AO2, which is an automated station. That means that these METARs are put out automatically. There's no person sitting there typing it all out. So automated station, and then the 02 is a sensor that can distinguish between rain and snow. If there was no rain sensor, it'd be A01. You'll see there are some other remarks back there, which I think we don't cover in this slide, but they do exist. And at some point here, there's going to be a link to a decoder guide that you'll be able to use if you have an interest in decoding those additional remarks. And one of the examples we have has a bunch of remarks in it as well. So you'll get an example of what's generally in that section. The P0050 is rain accumulation during the last hour in hundreds of inches. So in this case, that would be half an inch, because it was 50/100ths, which of course simplifies to 1/2. Depending on how long it's been raining or the severity of the raining, there may be additional values that show up after that for rain over a 6-hour span or a 12-hour span or something like that. And then lastly, you see that little dollar sign. Like everything in aviation, the sensors that create METARs cost a lot of money because they have airplane in them, and that just makes them more expensive. So something's broken and requires maintenance, kind of like a Mooney. But yeah, that's what the dollar sign there means.
You'll see a lot of remarks in these, especially when there's active weather going over a station like a thunderstorm or some convective activity. Not to say that those aren't important, but I think, for the flight simulator pilot, what you're probably looking at most of the time is the wind, the sky cover, and the altimeter. Maybe, depending on what the conditions are, the temperature dew point spread might be important as well. But for a lot of people, getting into the remarks and that detail is probably not a whole lot of people. That being said, it's really not all that hard to interpret, and a lot of the time, with these is an exception, but a lot of the time we're going to see a few examples later where the remarks end up just being almost like you're reading a regular bit of text with the vowels removed, so you can kind of sound out what it's going for a lot of the time. But I think for the average simmer, we're really looking at the wind, the sky cover, and the altimeter when we're trying to have a quick look at what is the actual weather doing at this airport or that airport.
And now we're going to go into some examples.
Not quite yet, actually.
Ah, well, I guess we're going to talk about this one first.
Yeah, so, here I think we're looking at just a little more detail on that sky cover section.
Yeah.
Yeah, so this talks about visibility and obscuration. So as we mentioned earlier, this is just another example of 5 statute miles of visibility. Important that this is statute miles, not nautical miles. They're close but not exact. METARs and weather will use statute miles. And then it uses cloud conditions in 100 feet above ground level. In this case, few 010 means few clouds, so 1/8 or 2/8 inches of, or 2/8 of the sky is covered at 1,000 AGL. Scattered at 3,500 and broken at 7,000 feet above the ground. And that's an important thing here. These values are always above the ground, not above sea level, so you have to factor in airport elevation when determining at what altitude the clouds are. And the last two categories of cloud coverage, broken and overcast, those define a ceiling. So you'll see VFR minimum say ceiling, or hear someone say, oh, the ceiling was 4,000. That means at that altitude, it was either a broken or overcast layer.
There's a question here, which I think was about to get answered, but Adam asked, what are different indicators of ceilings?
I'm not very sure what that question means, so if you could elaborate, that'd be great.
I'm gonna guess he's going for basically what you just said. So the definition of a ceiling being a broken or an overcast layer, and there's a third one I'll talk about in a second. But generally speaking, if we have a ceiling, that's indicating that 5/8 or more of the sky is covered in cloud. And so pretty much when you start to see broken or overcast, chances are you're not going to see a whole lot of blue sky. And if your plan is to fly VFR or visually in and around that area, if that broken or overcast layer is fairly low, the chances of that working out are pretty unlikely. You'll also see third ceiling, which will be presented as VV and then an altitude afterwards. And that's indicative of a ceiling that's basically obscured. So it's hard to tell, is it fog, is it cloud? And you'll usually see an altitude right after that. So VV003, for example, indicating that there's a ceiling at 300 feet, but that the weather observer is really having a tough time of distinguishing, is it cloud, is it fog? Basically, when you see that, it's not going to be great conditions for VFR flying or even IFR flying for that matter.
Adam, does that answer your question?
That looks like it's good.
All right. So briefly, we'll touch on VFR weather minima. Now, this is just kind of a generic what constitutes VFR weather. What is a bare minimum weather required for VFR flight? With that being said, this is not a hard, hey, as long as you satisfy these two requirements, you're good to go fly. No, it's much more complicated than that. It depends on the class of airspace. It depends on the time of day. And then from a, not just a legal perspective, but from a safety perspective, it depends on pilot proficiency, experience, what your own personal minimums are. But with that being said, as a bare minimum for VFR weather, you need 3 miles of visibility and a ceiling of at least 1,000 feet AGL. Now, if you were, for those of you that have undergone pilot training or are a little bit more familiar with some of the regulations that have been laid forth, you can't do very much with 3 miles and 1,000 feet. You're pretty limited, especially if you're trying to go cross country or something like that. So it's a minimum. It probably shouldn't be your minimum. And for example, with the PRP flights, soon to be the wings flights on VATSIM, for the VFR ones anyway, you need to have these requirements. As well, both in
for VFR, if a ceiling is at 2,500, for example, so do you have to fly below 2,500 if you're VFR?
Yeah, that's a good question, Alan, and it really depends on the class of airspace that you're in and the type of day. So the FAA establishes a series of cloud clearance requirements that include a visibility component, a distance laterally from the cloud, a distance above the cloud, and a distance below the cloud. So it does depend on the class of airspace and where you are, but generally speaking, in most classes of airspace, you will need to be 500 to 1,000 feet below the clouds to be legal. And if you'd like, I can find a chart that has all of that information.
Yeah, if you can, please, that would be appreciated.
Yeah, I'll pull that up here at some point in a minute.
And of course, let's remember that just because a cloud layer is reported somewhere doesn't necessarily mean it exists, right? So if the ceiling at the airport is reported at 2,500, but you're actually flying there and you're at 3,000 and there's no cloud, that's a perfectly acceptable place to be. So nobody's looking at the reported weather and saying, you're flying VFR, you may not be safe there. But of course, we want to make sure that as we do our flight planning and we're looking ahead, that we're not trying to actively fly into an airport or an airspace that might cause some issues for us.
Yeah, and that's a very good point, and that applies in the real world as well. Not just in the sim. I had a flight today that's exactly how it went. So you kind of need to be able to adapt on the fly sometimes.
Is it legal? This is a question for both of you guys because I don't know the answer. Is it legal in the U.S. to be flying above an overcast layer of clouds? So you're,
Yes.
basically on the top.
Yes,
That is
it's called
100% legal
VFR
under
over the top. It's not recommended, but it's legal.
And there's no special rating you need. Any other any random pilot,
Nope.
private pilot can do that. Yeah.
Again, not the smartest idea, but perfectly legal.
It's not legal for sport pilots.
Oh, good to know. Thank you.
Interesting.
There's some funny rules on how that works in Canada, and effectively it's not permitted without a special rating that you need. But you used to be able to get away with that because the definition of it just says visual reference to the ground. So we used to fly out in places where there were a lot of mountains, and you just, as long as there was one little peak of that mountain in between the clouds, you say, hey, I can see the ground over there, so I'm legal at VFR.
Nice.
That's the same requirements, actually, Evan, as a visual reference to the ground. for sport pilots, of course.
Cool. Thank you.
All right. So here are some examples for decoding METARs, and then there's going to be a TAF component as well. I believe Evan has pre-selected some very lucky volunteers.
Yes, I have indeed. So I've tried to give the easier ones to the beginning. So Jeff, if you don't mind kicking us off, don't forget to unmute your microphone here in Google Meet. And if you can just read for us from what you've heard so far, this first one, if you miss anything or if anything is not correct, Alec and Krikor will help you out and we can have a discussion about it. Again, no pressure. Appreciate you volunteering to step up and give it your best shot at decoding this first one.
All right, so this is the Bradley International Airport METAR. It was on the 15th of the month. It was at 2253 Zulu. The wind was 140 at 8 knots, and the visibility was 10 statute miles. There were a few clouds at 6,000 feet. The temperature was 32 degrees Celsius. The dew point was 19 degrees Celsius, and the altimeter was 2993, and the station had the automated rain and snow forecast or observation.
Cool. Very good.
Very nice.
So temperature is always Celsius?
Yes.
What's that?
Temperature
yes.
is always Celsius? Okay.
Yes.
Temperature and dew point in METARs and TAFs will always be Celsius.
Okay.
And we'll talk about how you can convert that in the next example, not to give away too much here. Just an interesting fact for people, if you've been flying on the network and you look at that first one, you see the wind 140 at 8, then you get to the airport and the controller says wind 160 at 8, runway 24, clear to land. That's because when you hear the wind from air traffic control or you hear it in the ATIS, we're going to give you the wind in degrees magnetic, which is how your compass and your heading indicator work. But the wind that you see in text is always going to be published as true. So if you've ever been wondering why there's that 10 or 20 knot discrepancy in the Boston area, that's why. And of course, it depends on the magnetic variation. So as you move toward the middle of the country, the true and the magnetic wind will almost be the same. And then on the West Coast, you have the opposite. It's 20 in some places, John.
Why is it done in such a way which adds extra work that you have to calculate? What's the point of it? Why not putting it magnetic?
What's the I don't have an answer to why METARs and TAFs are in true. I'm guessing that's just the way that the sensors have just historically been calibrated. Just know there's a good mnemonic to remember. It's if you read it, it must be true. So if it's a text format, like a METAR or a TAF that you're seeing online, it's going to be in true, degrees true. And if it's spoken to you by air traffic controller in an ATIS, it's going to be magnetic. As for the reasons between why weather is presented textually in true, I don't know. I mean, fundamentally, it's because the true North Pole and the magnetic North Pole aren't equal. Why weather is presented in true, I'm not sure. Maybe Krikor or Evan has an answer to that.
My guess would be that it's because magnetic north keeps moving, and so that would require a recalibration of the sensors every, periodically. But I don't know for sure.
One other thought as to why it might be the case is if you're flying over a large region, so you're doing a longer flight, you're looking at the upper wind, knowing the true wind would be more helpful for you because you're going to compare that to your track, whereas the magnetic variation is going to be different at all those different stations. So I think that could be one reason. But of course, if you're actually dealing with the local airport METAR, I don't understand why that couldn't be given to you in magnetic.
Sounds like last century. Maybe it's time to change it. Haha.
Yeah, I could be like that could be true. I'm just trying to Google as well, and I don't really see anything coming up right away.
Yeah, a small caveat note that actually Active Sky respects that. So you will see sometimes that the report is actually Active Sky does work that way. So it's kind of neat.
All right, who is our lucky individual for the second one?
Is Cameron. So again, don't forget to unmute your microphone and then give it a shot.
Oh boy. All right, so this is the Boston observation.
Just remember your approach certification that I'm going to give you or not give you. It hinges entirely upon this. Yeah.
Exactly. It was on the 15th month. It's the Boston 225 or Zulu observation. Wind 260 at 10, gust 17. Visibility 10. A few clouds at 35 Krikor. a few clouds at 3,500. The ceiling is 6,500 broken to 7,000 broken. Temperature 19er, dew point 11, altimeter 29er, 89er. And then you got the remarks. So it's the snow and wind sensor, automated observation. SLP is abbreviated for sea level pressure. And then 119. I believe AM taught me this, and it basically is the altimeter in hectopascals, if you guys want to correct that later. And then T is temperature. So the actual the observation temperature was 19er and dew point 11. The actual temperature is 19.4 degrees Celsius and 10.6 on the dew point.
Yeah, you pretty much nailed it there with the sea level pressure. It is in hectopascals, which is generally used overseas more than it is here. But it's 1011.9 hectopascals is what that would be.
Any thoughts on, anyone in the group can answer this, feel free to unmute your mic and answer. What is the purpose of having that temperature 19.4, 10.6? What do we really care about that, or any idea what it's used for?
It becomes very important once that stuff gets closer.
Definitely. There is another reason that they included as well. The other reason that I've seen for why that's there is to help with the conversion to Fahrenheit. So if you want to know the temperature in Fahrenheit, they've added the extra decimal so you can be more accurate in that temperature conversion, is what I've understood it to be. All right, next lucky volunteer is Sam. And let's see what we've got picked out for you. Oh, it's not too bad. Sam, don't forget to unmute your mic here if you're going to read out the Nantucket weather for us.
Yep. So it's the airport's Nantucket. It's the 16th day of the month and this is the 1853 Zulu observation. The wind is 230 at 8 knots. Visibility is 1 statute miles. We've got some light rain. We've got mist. Our ceiling is overcast at 800 feet. Temperature 20, dew point 17, and altimeter 293.
Nice. The baby rain. You managed to get that one. That was well done. That's often one that trips people up. And again, as we mentioned, there's that decode key. You can Google for that, or the link is at the bottom of the slide, and that'll help you when you encounter some of these different precipitation codes. A lot of them are based on the French word for the precipitation. So if you wonder sometimes how they came up with the acronym, often that's the reason. And
Yeah,
next up, go ahead.
BR doesn't actually mean baby rain. It's the French word for fog, which is brouillard.
And of course, it doesn't mean fog either. It means mist.
Yes. So logically,
bruin instead.
I'm sorry.
That would be for bruin instead. That would be mist.
Oh, yep. You're right. My bad. Yeah. Well,
So
you help.
while we're on the topic, does anybody know what the difference is between fog and mist as it pertains to a METAR?
Well, fog would not involve any precipitation, and mist is a very fine rain.
Yeah, there's actually a very specific requirement in what dictates if it's going to show up as fog or mist. Anyone? Evan, Alec?
I don't know.
Oh, I got it, I think. Condensation?
No. So it actually has to... Sorry?
Where the ceiling is?
Not ceiling, it's actually a visibility thing.
Would it be?
Less
Oh,
than,
is that the 1,000 meters thing?
I don't know what it is in meters, but if it's less than, I think it's 4/8 mile visibility, it's considered fog, and if it's greater than 4/8, it's considered mist.
Yeah, I've heard 1,000 meters fog is the defining point.
But yeah. All right.
Well, if we're good to move on, Will is up next. So, Will, if you want to unmute and do your best with this one.
This is the... First off, can anybody hear me?
Yes.
Yep. All right. This is the Boston Airport on the 15th of the month at 2254 Zulu. Winds are 260 at 10, gusting to 17 knots. 10 miles visibility, few clouds at 3,500. And then the ceiling at 6,500 broken and 7,000 broken. 19 degrees Celsius, dew point is 11 degrees Celsius, altimeter 29er, 89er, and once again, just the automated, can differentiate snow and rain with the same sea level pressure and the specific temperature. I think it's actually the exact same as the 1-2 above.
Yeah, it's funny. We've done this. We've done this for 3 years, and I don't think anybody has noticed that. That's good. We were just commenting on that and hoping nobody was going to see it. So I will have to make a change to that one after the end of the presentation. Thanks for pointing that out. But hey, you know what? You did a good job with it anyway. It sounded like you were going through it and doing it for real. So that's good. John, we've saved an extra special one for you up next. Of course.
Have a crack at it.
Great.
Yeah.
All right, so this is the Denver International Airport automated weather observation. 15th of the month, time 2253 Zulu, wind 33012, visibility 10 statute miles. It's light thunderstorms and rain. Let's see, cloud cover 6,000 scattered, and the CB denotes cumulonimbus clouds, so thunderstorm forming clouds in the area. Ceiling 7,000 broken, 10,000 overcast. Temperature 23, dew point 15, altimeter 3015. Remarks. So the it's got the automated system with a precipitation discriminator. Peak wind was at was 350 at 38 knots at 2159 Zulu. Let's see.
As he clicks around there to see what the other ones are.
I can tell you sea level pressure. That's telling you that there is occasional, there's lightning observed, light icing. Let's see what else. And then it's telling you where the clouds are located in the area, as well as the peak precipitation. That's the best I can get out of that.
So you got most of it. I've got a couple little things for you, and then we'll go through all those remarks because there's obviously a lot of them. So what is a light thunderstorm?
So it's thunderstorms, light rain.
Yeah, and this is one that confuses a lot of people. And the way the FAA puts it out really doesn't make a whole lot of sense because that's what it says is light thunderstorms with rain. But it actually means thunderstorms with light rain. Yeah, I don't know why they did that, but that's what they did. Peak wind, you got that. The rain began 43 minutes after the hour. So that would have been 2243 Zulu was when the rain began. That's what the RAB is. Sea level pressure 1013.7. You got the first part of this one, but this one is another one's a little bit confusing. So it's occasional lightning in cloud and cloud to ground is what that little block there is. In the distant south and southwest, distant being more than 10 nautical miles, or 10 statute miles rather, cumulonimbus clouds in the distant south and southwest, moving to the southeast, and then no precip within the last hour, and then the specific temperature and dew point. So there's obviously a lot of remarks there. In general, it usually, like Evan said, is relaying bad weather and stuff that you don't want to be flying in, and is usually indicative of some sort of convective activity. And the ATC meme stereotype, the little TAF decoder with the ruler and the lengths on it, is somewhat accurate in that sense.
Couple of questions there in the chat if Krikor and Alec, you want to address those ones.
Yeah, so it looks like the peak wind question has been answered, but yeah, Cameron, that 35038/2159, that's a peak wind. So peak wind of 350 degrees at 38 knots observed at 2159 Zulu. Let's see.
And I can grab Will's question. It's
could you read that out as well for the recording?
Yeah, I have tried to look up information, but the article said this is not the altimeter setting in millibar. So this millibars and hectopascals are the same thing. It's the same one-to-one conversion. So I guess I'm confused by your question, Will.
So it's yeah, that by itself is not an altimeter setting. But it is a barometric pressure reading, and they've just shortened it for the purposes of the METAR and trying to take up less space. So what you want to do there is take those three numbers, so 137 in this case, add a 10 at the beginning, so 10137, and then make the last character after a decimal place, and you'll get 1013.7 hectopascals. It's just an alternative reading of barometric pressure.
Maybe a better question is, I don't know, I've never found one. Does anyone here have a use for it? Because I've never used it.
So this is Will. So the articles that I've read, they have said that it's not just taking the altimeter setting of 3015 and turning it into the millibars of 1013.7, that it actually has to do with the reason it's called sea level pressure is it's like if that pressure reading was taken at sea level, so it was doing some kind of altitude compensation, so you'd understand like how much higher or lower it is than it should be just based on the altitude. And I was wondering if you had any more information, because I kind of understand it, but I wondered why it would be useful and if that was even the right interpretation of the stuff that I'd read about it.
Yeah, that's an interesting point, and I don't know any more on this, so I'm not 100% sure on that. But what I will say is that an altimeter setting works the same way. So the rule of thumb is that the barometric pressure will decrease by a inch of mercury per 1,000 feet that you climb. So if we were at Denver, right, like in that example there, we have the Denver altimeter of 3015. The barometric pressure at Denver is not actually 30.15 inches of mercury. It's actually something considerably lower than that, and that gets corrected with altimeter settings as well.
But again, I can't think of an actual practical everyday use for it. I'm just in some reading that I'm seeing here. There are obviously, as Krikor said, some altimeters that actually reference millibars. And so if I guess you had one of those altimeters, it could be that that's the reason it's published, but I've never had any practical use for it. You just use the altimeter setting that's shown, and I've never used sea level pressure for anything other than to have to answer questions about it on exams.
But yeah, that's as much as I know on the subject.
So Jackson, you're up next. We've saved the first and only TAF for you. And so we'll see a few new things that come up in this next example. If you want to unmute and then do your best at deciphering this upcoming TAF. And I guess we'll give you, we have a METAR there. Sorry, actually, it's TAF all the way through. We'll give you a couple lines to read through and tell us what you think.
Okay. So from the 16th day of the month at 0 Zulu, so midnight if you're in what UTC time. Okay, so 15211624, no idea. Wait, that's okay. That's the METAR at the top. And
Looks like it, but it's not.
TAFs, right?
Looks like it, but it's not.
Okay, I got it. So that's that, and then under that's the changes per hour.
Okay, I like that. So far, so good.
Okay. So I'm going to skip those 8 numbers, and then the winds are 220 at 6, plus 6 to 2 miles, I think. I don't know. Scattered at 1,200, broken at 5,000, and overcast at 10,000. And then from the 16th day at 0 Zulu, the winds are variable at 3, plus 6 to 2 miles, scattered at 5,000, and overcast at 10,000. And then from 1300 Zulu, same day, variable at 3, plus 6, and overcast at 1,200.
Nice. Nice. Before we talk about anything else, does anybody want to help them out with what those 6 numbers, 1521/1624, are about?
I can. So this means that this TAF is valid from the 15th day at 2100 Zulu to the 16th day at 2400 Zulu.
Thank you, John. Krikor, Alec, anything else to add?
Nope.
I think we pretty much covered it.
Jack, I just want to remove any unclarity. P6SM does in fact mean plus 6 statute miles, so we know that it's going to be at least 6 miles. Jackson was right.
And thanks to everybody who volunteered. Jeff, Cam, Sam, Will, John, thank you guys. Jackson as well. Thank you very much for the volunteering and for putting yourselves out there. Appreciate that. And for those of you who didn't, hopefully you were following along. Again, that METAR decode key at the bottom of the slide, which also was posted in the chat for you, is a great resource when you find an unencountered or previously unencountered abbreviation like FU in the METAR, and you think the guy who wrote the weather's angry at you, but you find out actually it's just smoke. That was a weather joke.
All right. So moving on. Alec, you want to take this one?
There are a bunch of different resources we have to check the weather. First and most common to get a good big picture item is SkyVector. The way that you can do that is you can go click Layers in the top right corner. Then you can click various different things like temporary flood restrictions or TFRs, and then the weather radar. And the weather radar is really what shows any reflections from weather radar, like precipitation. And it's a good idea to be cautious of little green dots, unless, Krikor, we cover this on the next slide. I can just talk about it now.
Okay.
Do we cover it in the next slide?
No.
Okay.
I don't think so.
Okay, so we can just go over it now. This is it's a good idea to not blindly trust, oh, an airport is VFR right now, let's go fly. Because if you look at that airport, I can't really make out what it is from my computer screen. But if you look at the airport, in the middle of the screen is surrounded by the VOR, it's green. It means it's VFR. At that moment, that airport is VFR. But if you look immediately west and east of it, it's surrounded by pretty massive thunderstorms. So it's always a good idea to get a big picture layout of the weather for a certain area rather than just blindly trusting METARs.
Yeah, and again, the green also just indicates that it's VFR. So the airport that we see right in the middle that Alec was referencing that has that green dot, it could well be a layer of broken cloud at 1,100, or it could be a few layer at 1,100, but we still don't want to be necessarily flying around in clouds that are that low. So generally speaking, to get that big picture look at an area, if there's a bunch of green dots, you're probably doing fairly well, but you'll want to actually delve into the individual METARs and make sure, is this airport actually looking good? What is the actual cloud layer that we're going to be dealing with in this area? And using some of the other tools in these layers like the weather radar, SIGMETs, and other products that are available can be helpful to your planning as well.
Another really good resource is the Aviation Weather Center, which is aviationweather.gov. This is a real-world resource. I teach this to my real students and get them to use it. And a lot of these products are available on applications such as ForeFlight as well. There are links under observations where you can find forecasts, or sorry, let's try that again. There are links under observations where you can find observations, such as METARs. There are also under forecasts, there are a number of tools, including the prog charts, which is what you can see here. The prog chart shows big picture weather systems across the United States. So quickly you can see all the H's are high pressure areas, L's are low pressure. It shows you cold fronts like this blue line with all the triangles up top. There's not really a warm front on here. There are stationary fronts, which are these mix of the blue triangles and red half circular guys. Troughs, which are extended areas of low pressure, which are these orange dot/lines. You've got readings of barometric pressure, and those are in hectopascals. And some other information on these. This would be a most recent issuance of a prog chart. One that's a little bit further down the line and more of a forecast also shows the chances of thunderstorms and precipitation and ice and snow and all of that very fun, exciting stuff. On the right, same thing. It's another version of the another forecast that shows areas of IFR, marginal VFR, turbulence, and other items such as that. There's a whole bunch of tools. I'd certainly recommend the usage of aviationweather.gov for flight planning and looking at stuff. Just again, make sure that this is something where, you know, you may know where a cold front is, but we haven't really talked about what a cold front is and what kind of weather that brings with it. So just make sure that if you're actually out there flying or you want to learn more, talk to a CFI or someone who can give you a little bit more information on that stuff.
We have more resources like Flight Plan Go and ForeFlight. We're not going to delve too much into this. Just know that there are a plethora of resources out there for all of your flight planning needs. Some resources like ForeFlight, if you're a real-world pilot, or Flight Plan Go combine both weather planning and route planning, so to help figure out what a good route is, what air traffic control is used, but we're just offering you a bunch of different online resources that you can use.
And Flight Plan Go, which is primarily an Apple iPad app, I'm not sure if they have an Android version, is a really great tool. They actually have a utility you can download that lets you connect your simulator to your iPad. So you'll be able to see your position from the simulator on the iPad. And it's actually geo-referenced with various instrument approach charts. So as you're flying the ILS, you'll see your little airplane actually on the ILS chart. Same for the en route charts and same for some of their weather products. Flight Plan Go also has access to Canadian charts, which is the only app I'm aware of that gives those away for free, because otherwise you have to pay for them. So it's a fantastic free app. You can get it from flightplan.com or just search Flightplan Go. And as I say, there's even a tool that lets you connect your simulator to it. So the position that your iPad is getting is coming straight out of your sim.
All right, and just before every flight, you want to get the big picture on something like SkyVector. That's going to show you where there's a lot of weather. We talked about be careful of green dots. Weather can be deceiving. Oftentimes, those weather radars will show precipitation, but they don't show anything as far as clouds and buildups. And especially if you're flying a small airplane, you don't want to be flying through a lot of large buildups. Because they could still be developing. There could be a ton of up and down drafts, and it could be very unsafe. So make sure you do some thorough pre-flight looking at weather and finding what's acceptable to fly in and what's not. Find the areas you want to avoid. A lot of the times, real airlines will plan routes around large weather, large thunderstorms or convective activity or things like that. So you may be able to find those routes off of FlightAware and use those to avoid bad weather. Or you can fly into bad weather if that's what you want to do, I guess. Check the METARs and ensure you have good VFR weather. If you're flying VFR, you probably want to know where the clouds are at. What's the visibility like? If you're flying VFR, there's a good chance you're in a smaller airplane that will be more susceptible to gusty wind or crosswind conditions. So that's something you're going to want to consider as well. And then get the winds aloft and temperatures. That'll make a big difference, especially if you're using something like Active Sky. That's going to really impact the time it'll take you to get somewhere, your ground speed, your fuel burn, all of that stuff. If the temperature is low enough, that could lead to icing. Even in the summer months, there was down here in Tennessee today, there were a couple PIREPs for ice at flight level 200 by twin Cessnas and stuff like that. So ice affects people even in the winter month or the summer months rather, because of how cold it gets aloft. So that's useful information to have as well. And that's pretty much it, guys. Like we said, this has been a pretty basic overview of weather. We really didn't delve into theory behind weather and stuff like that. So we're not planning on really getting into too much weather theory over the course of this set of ground schools. But if any of you guys have questions about it or want to talk about it, I'm sure Alec or I would be more than happy to sit down and talk to you about weather in depth. Otherwise, we hope you've all enjoyed, and we look forward to seeing you next week on the... What is next week? The 29th at 8:30 p.m. Eastern time again for VFR departure and arrival procedures.
And folks, if you have questions, we will be in the TeamSpeak to help answer those. So if you want to move over to TeamSpeak, mute yourselves. If you have any questions that you'd like to ask Alec, Krikor, or myself for the next couple minutes, feel free. And as Krikor says, otherwise, we hope you can all join us this time again next week on Wednesday, the, as you said, 29th, to talk about VFR procedures.